Dear student, today we'll discuss a very important concept of machine learning, and that is called PCA. PCA means like a principal component analysis. So principal component analysis is basically is used for dimensional reduction, because sometimes when we are doing prediction, so there are some dimension or attributes or fields or columns or factors which are redundant, or which are like not directly related for the prediction. So we need to choose, we need to select like certain attributes, so that like it becomes robust our algorithm, or we can have like a good decision. So let's see that how it works, what are the dimensional reductions, and how can we use it, the PCA, for that purpose. So in short, PCA is a dimensionality reduction technique that transforms a set of features into a data set, into a smaller number of features or columns, right? Called PCA, or principal components, which at the same time trying to retain as much information in the original data set as possible. So you can see here in this one, just like, let me highlight this for you. Yeah, so here, this one is a bigger full data set, and it has how many columns? One, two, three, four, five, six, seven, and eight. Eight columns. So sometimes these eight columns are not like needed, or we don't want to use all this one. So let's suppose we need three columns: one, two, and three, right? Along with the label, right? The label will stay with us, right? So from the eight different columns, we have reduced to the three columns. So this is the main function of the PCA, and right. So now we have three columns here, and here we had the eight columns there, right? So the transformation of the eight columns to the three column, this is the main function of the PCA. Yeah, so what is the advantages of the using PCA? Like sometimes it removes the correlated feature, because for example two feature might be like similar, like for example phone number and email. So sometimes we need just one thing, email or phone number, or sometimes we need like like permanent address and home address. So address is just like we need one address. PCA will help you to remove all the features that are correlated, and phenomenon known as multicollinearity. So that is called multicollinearity. So related feature are like picked one feature. Finding features that are correlated is the time consuming, and especially if the number of features is too much large. Let's suppose if we have 20, 30, 50, 100 features, right? Especially in image recognition. So improves machine learning algorithm performance. With the number of features reduced with the PCA, the time taken to train your model is now significantly reduced, and the time will be reduced. And now we have like GPUs and like supercomputing, but still like it's better to have a reduced time. Reduce overfitting as well. By removing the unnecessary feature in your data set, it helps you to like overcome the overfitting problem. Standardize the data. So first you need to standardize the data. Standardize the is the process of scaling the data in such a way that all variables and their values lie within the similar range. Like it should not be one extreme value, another smaller value, or there should not be like irregular values. The formula for standardization is xi minus mu divided by sigma. So z value, so where xi is the observed value and mu is like the sample value, okay, and mu is like for example like a mean value, and sigma is the standard deviation. So by this one we can have a standardized data. Calculate the covariance matrix. So covariance we can also find it in Excel as well. There is a formula as well in Excel. You can easily equal sign COV, and then you can easily find it by selecting both the data, or you can find it manually by this formula. So covariance matrix expresses the correlation between the different variables in the data set. It's essential to identify highly dependent variable, because they contain biased and redundant information which can hamper the overall performance of the model. So what is the variance? So variance, we already know that like variations from the standard way, or from the mean. So yeah, so this was like a correlation, like, and a correlation is like a yeah, so correlation we already standard deviations, mean values. So yeah, so correlations is basically we can use values from -1 to +1. Yeah. So PCA, if our data set has more than two dimensions, then it can have more than one covariance measurement. For example, if we have a data set with three dimensions, X, Y, and Z, then covariance matrix of this data set will look like this one. So see, we have like covariances with x-axis, x, y, x, z, y-x, y, 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 z, and zx, zy, and zz, right? So all our combinations are then here. And then PC, like, so we can see PC1 is like 15.84% variance and 10% variance, and the lower variance is in PC3. So PC3 has a lower variances with respect to the data points spread. So calculating the factors and eigenvalues. In the mathematics, this is very important factors, and you can use matrices for this one if you do it manually. So eigenvectors are those vectors when a linear transformation is performed on them, then their directions does not change. Yeah. So eigenvalues simply denote the scalar of their respective eigenvectors. Let A be a square matrix, V is a vector, and lambda is a scalar that satisfies this equation. So AB equal to lambda V. Y is called the eigenvalue associated with the eigen V and phi. So eigen was a mathematician, and on his name he gave this values. So he invented this one, and he wants. So let's suppose this is the matrix. In matrix, what we keep it, we keep the data, and we multiply a vector A with another vector X. Okay, so this is just like a simple multiplication which we learned in the high school, and then you get we make a common two of that one, and we have a simple matrix of it. So we can say it's a 2 of X basically, which is actually ax is equal to 2 of x. So we have reduced the dimensions very narrowly. As we can see in our above calculation, 1 is the eigenvector, okay, and 2 is the eigenvalue. Now let's see how we can find the eigenpairs of the sample vector A. Yeah. So here is some more calculation on this one, replacing the value of our vector A in the above formula. We can have also some simulators for that one. So to make your work easy, but just to understand the concept is that the purpose of all this mathematics is just to find the lambda value so that we could reduce the dimensions. Yeah, so with the found eigenvalues, let's try and find the corresponding eigenvectors which satisfy this value. So Ax is equal to lambda x, and for eigenvalue y equal to 2, and for eigenvector lambda is 3. So if lambda is 2 and lambda is 3, what are the different values for x1 and x2? So x1 and x2 variates over here. Now here we can say width and height of the different fish, right? And we can see their different dimensions, width and height, and accordingly we can reduce the dimensionality and find space that which maximize the variance of the projected data. Okay, and then we have these values with the different dimensions, x, y, and z dimensions. In nutshell, what is PCA? So you can see over here in one correlation high dimension data and means height in the probability. So here you can see this is one thing, and then center the points, and then we have third compute the covariance matrix. We need to find the covariance, then we need to find the eigenvectors and eigenvalues. So eigenvectors are the matrix basically, and values are the values which you take it common from it, and then pick m less than d eigenvectors, highest eigenvalues, and on the 6 project data points to those eigenvectors, right? And uncorrelated low data. So this is that how it works. So I hope that you have some idea of this PCA, that how it works. So this is like complete flow diagram. And this will reduce your dimensionality, and you will have uncorrelated low data.